Okay, 7.6 or 7.7b, page 10 of the note, 7.7. Okay, so on here, a lot of this is already written on here for you. Exponential decay. If you think of decay, it's kind of the way things work. Things get worse and worse and worse and worse. That's kind of decay. So a graph of decay usually looks like this one over here that you see on the screen. It starts up high and then it ends up going low, and that's an exponential decay. Exponential growth, which we already covered, looked like this, where it grows as it goes to the right. Okay? Now, one of the things, the base, B, will still have that same formula we've been looking at. This will be your initial amount, or your starting amount. This, when we're dealing with this, is either the growth, or in this case, since we're dealing with this, is the decay factor. So B is either the growth or decay, depending on which one we're looking at. Today we're looking at decay, so it'll be the decay factor. What we talked about when it was growth, it had to be a value that was bigger than 1. So like it could have been 2 or even 1.1 or something like that. But with decay, it's got to be less than 1. So it could be like something like 0.7 or 0.1 or something like that. It's got to be smaller than 1, meaning it gets smaller. Only 70% of it would be there if we had 0.1, for instance. It's got to be a value between 0 and 1. So it could be anything. It could be like 0.1, 0.2, 0.3, 0.11, something like that. All right? Over here, we're going to graph by making a table. So if you have a calculator, we're going to fill this in, and I know it's really small, but we have this 1/2 to the x. So we did this a lot in the last few weeks. We take our value 1/2 and we raise it to the x. So in this case, the first value it wants us to put in is -3. Now you may want to put a dot on there in case it's going to make it some sort of a decimal, but that one just comes out to a plain old 8. So we're going to fill that in our table. Then you're going to put -2 in. So again, you grab your calculator. Now, if you have one of these, you can go up, you can highlight it like I did, and you can press enter, and then you just back up enough to put the 2 in there. That one comes out 4. And since I have it on the screen, I'm just going to put it in the -1 real quick. It goes pretty fast if you highlight it that way. We know anything to the 0 power is what? 1. Okay, so it should go 8, 4, 2, 1. Notice how it's dividing in half every time. That should make sense when you look at the formula because it's going to be half as big. So what it is doing is it's decaying. I'm going to start to graph some of these on here. At -3, -1, 2, 3, I'm going to go up 8. 1, 2, 3, 4, 5, 6, 7, 8. The next one over at -2, it's only 4 tall. It's half as tall. That's decaying. It's getting lower. Then at -1, it's at 2. At 0, it's 1. So now what happens if I put 1, 2, and 3 in? It kind of feels like, well, it can't get any lower, but it actually can. What's half of 1? 0.5. Okay? So you could put in 0.5 or you can put in 1/2. What's half of 0.5? Half of 50 cents. 0.25. Yeah. Half of 25 cents? 12.5 cents. Okay? So, I mean, a lot of times if you think of it in money, it can help you to think through some things. That's always been something that's helped me. Okay, so in here we put in 0.5. So at 1, 0.5, 2.25, getting lower, and then 0.125. It's kind of hitting the line. Don't go below the line. Try not to do that. The goal is that it actually stays above the line. But then we talked about this a little bit last time. That's supposed to be an arrow on the end there. The domain is all real numbers. The range is y is still greater than 0. Good. What happens to the output as the value of x decreases? If x decreases, if x gets smaller, the output, or y, gets bigger. When x gets smaller, if I go this way, the y's are getting bigger. But if x increases, then the y gets what? Smaller. We saw as we went to the right, everything got lower and lower. It got closer and closer. Now, this brings up an idea here of what we call an asymptote. We aren't going to talk about this. Maybe I'll throw it on as a bonus question on the semester test. Next week, semester test. Ours is next week, Thursday, in here. So, first test of the day, second period. So, the idea of an asymptote is this idea. If you walk to the wall, if you're 4 feet from the wall and you walk half the distance, how far are you from the wall now? 2. Now you walk half the distance again. Now how close are you? 1 foot. Half of 2 is 1. Now you walk half of what the remaining distance is. Now how far are you away? 6 inches. Let's call it 0.5 feet. It'll be easier. 6 inches is correct, though. Half of that is 0.25, or 3 inches. Half of that, 1.5 inches. Half of that, 0.75 inches. If you keep walking half of what's left, will you ever hit the wall? There's always something left, and if you only walk half of it, you don't actually touch the wall. You get really, really close, but you could be one millionth away, and if you walk half of that, now you're 1/2 millionth away, right? You'll never hit the wall. And that's the idea of what we call an asymptote. This line here is what we call an asymptote. The graph of our exponential function won't actually hit it. It gets closer and closer, but never touches. Okay? All right. Now it says graph the following and compare to the parent function. Now we already have some of these on here. For instance, we did some of these because it's the same equation. It's the 1/2 to the x. When we put in -1, we got 2. When we put in 0, we got 1. It got half as much. When we put in 1, we got 0.5. When we put in 2, we got 0.25. When we put in 3, we got 0.125. So I'm filling those in quick. We didn't put in 4, but if I put in 4, I get 0.0625. If you want to put that in your calculator, you sure can. But now what we're going to do is we're going to compare this to other graphs. What happens if I were to put a 3 in here? And notice, here, there's nothing. There's actually a 1 in front of the 1/2. Here, they've put a 3 in. What happens to all those numbers if I put them in? But I put in the 1/2 and I put in the negative. What was the first one? -2? -1. -1. I got 2. If I do the same thing, but I put a 3 in front of it, all it does is make it 6. So this one here, this makes it 6. When I put in the 0, I get 1. What do you suppose happens when I put in the 0 here? What do you think we get? I put in the 0, I get 1. But when I put the 3 in front of it, what do you think I get? 3. Okay? So what do you think we get when we put in the 0.5? What's happening to all those numbers? They're all shrinking, but what's happening when you compare this one to this one? Times 3. Good. So this one would be 1.5. It'd be 3 times as big. This one, 0.75. 3/4 is 75 cents. This one, 0.375. This one, 0.1875. So how do you suppose it's going to change if I change one more thing and I slip, instead of just a 3, it's a -3? What's going to happen to these numbers? They're all going to change to negative. So instead of 2, this one's -6. It would be 3 times as much, but then negative. This one would be -3. This one would be -1.5. This one -0.75. This one -0.375. This one -0.1875. All negative. Now, how do we compare those graphs? If we were to graph them, this one with the 3 in front, it's 3 times as tall. If we were to graph them, the way they would look, the first one, I'm going to graph this one here in black quick. I'm just going to graph a couple. You can graph with me. At -1, we're up 2. Then we're up 1. It would look like this. Next one, I'm going to graph this one in red. At -2, it's up 6. Or at -1, it's up 6. Sorry, it's supposed to be -1, up 6. And then at 0, it's up 3. It's taller than the black one, but it's still decreasing. So the domain of this one in red is still all reals, and the range is still y is greater than 0. This one I'm going to graph in green. At -1 for x, I'm going to go down 6. Then at 0, I'm going to go down 3. How does it compare? It's 3 times as tall, but it's also what we call a reflection on x. Because that green one, it flips over the red one on the x-axis. Mirror image. The domain, again, is still all reals, but the range now is y is less than 0 because it went below the x-axis. Everybody got it? Now, without graphing, can you describe how these would compare? How's this one going to compare to that one? What's the difference? There's a what? There's a 7. So this one will be 7 times taller, right? How will this one compare to this one? 5 times taller. Still the same thing. When you add those numbers in front, that's what that does. Okay, graph and identify the domain and range. So to do this, you may want to make a little table and use your calculator. Now, every student asks, well, where do I get the numbers? You just come up with the numbers, and you just have to have a couple of them, okay? Because really two, and you probably will get the idea of where it's going to go. But common numbers to use would be like -1, 0, and 1, because they're really easy numbers. 0, because a lot of times when you put in 0, it turns it into 1, right? So we try them, and you're like, well, where did the numbers come from? Again, I just made them up, and I picked easy ones, -1, 0, and 1. Okay, so I'm going to take my 1/5, put in, whoops, raise it to -1 power, and it gets me 5. I know when I raise it to 0, anything to the 0 gets me 1. When I raise it to the 1, it gets me 1/5. If I make it a decimal, that would be 0.2. So I put these in my table that I made. This is 5. At -1, I then go up 5. At 0, I go up 1. At 1, I go up 1/5 or 0.2. Now that gets me that graph. Domain is all reals. What's the range? Y is greater than 0. Now, is that easy enough? So this one, I make a little table to help myself graph it. I'm going to start out with -1 and 0 and see if that's enough to get me the idea. I'll put in -1. Clean up my calculator screen here a minute. 1/3, raise it to the -1, I get 3. 1/3, raise it to 0, I get 1. You might say, well, what about 1? You can do 1. This will be enough for me to get the idea. At -1, it's up 3. At 0, it's up 1. Can you see it's going to come down? If you put in 1, it's going to get you 1/3 or 0.3. It's getting even smaller. So it's one that's coming down like this. Domain is, again, all reals. And the range, y is greater than 0. All right, what do you suppose, without doing this next one, what do you suppose the domain's going to be? All reals. Now, if you compare it to the other ones, what do you think the range will be? It's going to be greater than 0 because it still looks the same. It's still a positive fraction, right? So now you can put in some numbers. If you put in -1, when we had 1/5, we got 5. When we had 1/3, we got 3. When we put 1/4, what do you think it's going to be? 4. Yes, that's correct. After a while, hopefully you get some of the math where you can make the connections and see the pattern. And if we put in 0, we get 1. If we put in 1, we get 1/4 or 0.25. But what we'll see is this thing's getting smaller. And these three, they all really look the same, all three of those, right? Okay. Everybody good on this page? Okay, a little longer one today. Okay, now it says graph to compare. Okay, all I'm going to do, I don't think I need to graph these to compare. What do you think this one's going to be compared to that one? Okay, 2 times taller. The domain is still all reals. And the range is y is greater than 0. But now the trick. This one, there's a negative in there. So what's it going to do? It's going to reflect on what? Reflect on the x-axis. Means it's going to flip it over. Okay? So instead of being up here and going down, it's going to be like this. It's still going to be 2 times taller. The domain still will be all reals, and the range will now be y is less than 0. So it's learning to recognize what those things do. Now, we could graph all those. We could make little tables for them all, but we don't have to if we understand what some of those numbers do. All right, I think that is it for that one. Is at the bottom of that page.